What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Today we're going to be going over more Chem 118C Midterm 2 prep. And here I have a problem for you guys to work on. Go ahead and pause it, work on it, see if you guys can figure it out, and then we'll work on it together, alright? Cool, let's go ahead and talk about it. So this is a synthesis problem, and we start with a basic benzene ring, and we have to sort of add some things to our ring. Now these benzene ring reactions are a little bit different from Chem 118B reactions, but they have some similar logic. So there's going to be some review, but there's also going to be some new content mixed in there, okay? Let's go ahead and jump in. So first off, I need to add... I know that the new reaction that we learned for this Chem 118C is I want to eventually get to maybe adding some nitrogen groups to my benzene ring. So let's go ahead and add HNO3, H2SO4, because I know that's going to be a really good place to start. Alright, now that I have my NO2 group there, and I know that Chapter 21 deals with a lot of amines, let's go ahead and change that NO2 into NH2. And see what happens. So I'm going to react it with SN and HCl. Now I have NH2. Now I have NH2 is an ortho-para directing group. So I know I need to add an OH in the para spot, and I need to add a BR in the ortho spot. So let's see, which one are we going to do first? Are we going to put the OH in the para spot, or are we going to put the BR in the ortho spot? Well, if I actually protect this NH2 group, I can make it pretty bulky and add something specifically para, and then eventually take off my protecting group, and then perhaps I'll be able to add just ortho to that. So let's go ahead and see what happens if I block this group and make it very bulky. So remember which reagents we're going to use to make NH2 into a good protecting group to make it bulky? Yeah, we're going to use CH3, C double bond O, C double bond O, CH3. Good, so we're going to go ahead and do that, and that's going to make this NH2 group bulky. Now that I have this bulky group attached, I can add something to the para spot relative to my big bulky group. So let's go ahead and add an NO2, because I know that eventually I can turn my NO2 into an N2, which is the new reaction we learned from Chem 118C. Let's go and see what happens. Now, the reason I added an NO2 group first and went through this whole reaction instead of adding the BR group first is because notice my NO2 group here, this is a meta director, and meta relative to my NO2 is the location for the BR. So that's perfect, right? So now that we have a meta director, I can use BR2 and FeBr3 and get my BR exactly where I need it to be. So now that we have our BR spot taken care of, I know the special reaction to change NO2 into N2 plus is SN and HCl and NO2, right? And that's going to be important because I know that there are so many reactions we can do once we have N2 plus on our benzene ring, right? There's so many reactions. So let's go ahead and do that. Now, to get rid of my N2 and add an OH group, it's essentially putting copper 2 and oxygen and H2O. It's kind of like hydrolysis, and we're putting that water group in that location, switching places with the N2. Alright guys, we're almost done. We have the OH taken care of, the BR group, and now all we have to do is get rid of our big bulky NHC double bond O CH3 group. I can do that with some simple hydrolysis in basic medium. That's going to bring it all the way back to the NH2 group. I can turn my NH2 group into N2. We know that once we have N2 plus on our ring, we can do all sorts of things. And in this case, we're going to use CuCN and H3O plus, and that's going to give us all the way to the carboxylic acid. So let's go through that step by step. So in order to go here, I'm going to use H2O, OH minus, and heat. That's my first step. That will take my NHC11OCH3 group, and it's going to turn it into an NH2 group coming off of my ring. Step 2 is reacting the NH2 group with NaNO2 in HCl 0 degrees. That's going to turn my NH2 group into the N2 plus. Step 3 is going to be CuCN, which will essentially take a CN group and replace that with the N2. The N2 will be replaced and the CN group will go in. And then finally, we know that if we did hydrolysis of a cyanide group, that will take us all the way to the carboxylic acid. So step 4 will be H3O plus, or we could do H2O, OH minus, and heat. But I'm going to stick with H3O plus for this problem because I want my carboxylic acid to have its proton not get deprotonated. And I think if I was in a basic medium, then I might lose that proton. So this will take you all the way to our final answer. Okay. All right, guys. Thanks for tuning in, and we'll see you next time.